which was set for me, and that was actually the biggest thing for me. That transformed my whole life.
We have been molded into different engineers altogether.
When we participated for the first time last year, the major learning was that we had guidance, we had mentors with us, we had the resources, but we had to do all of the learning by ourselves. And wherever we got stuck, we had to come up with a solution by ourselves. So that made us self sufficient and self reliant. Instead of going to other people for answers, we started searching by ourselves. So that was a very important or key aspect that anybody can learn in their life, to rely on themselves. While we were implementing this, initially it was all software based, but when we went to the practical side of it, so things got really like messy. And just before our task force submission, the we were not able to balance our bot. And so yes, we were very discouraged and demotivated for a while. Like, we were sad because we really wanted it to work, but then we kept on going. We did not give up. And so one thing led to another, and within a week's time, the bot was balancing itself, and like it was balancing on the bridge so successfully, and we were really excited. Once we it started balancing itself, we got hope, and with that hope and motivation, we worked, and the final result was what all of us watched.
Since we have participated twice in EYRC, in the first year, we were immature, or say we were not able to solve problems, we were not able to identify problems. And even if we were able to identify problems, we were not able to solve them, or we used to give up easily. We don't used to manage time that time. So we used to work like day and night, but productivity, efficiency, you say, was like somewhat very less. But this time we worked less, but productivity and efficiency was more. We used to solve equations, algebra in class for marks, but here we solve it for solving a practical problem. So there's the difference. You're not just solving the equations for scoring. You are doing it for a practical problem which will be solved by your equations. So that's amazing.
e-Yantra is a transformative experience. Earlier, I was just a kid, who had a lot of interest in various kinds of technologies, and I wanted to learn. So, but through this competition, I have been transformed into an engineer with much more enhanced practical knowledge and working of the real world and its problems.
I have two words, like first is game changer and second never give up. Game changer is like it changes, like transformation of every perspective, like technical perspective also and non-technical perspective also.
E-Yantra is just a test of our grit and persistence. It spans over a full 6 months. Most of the other teams that actually participated the previous year in our college actually dropped out of it, saying that it was a really long-term investment. But we went on participating in the next year also, because we thought that this long-term investment will pay off.
Well, good evening and welcome to yet another episode of Kavi's Corner. And today we have three experts in the area of electronics, communication technology, and protocols. And we've entitled this episode Cool Communication Technology and Technologists. So, without much ado, I'd like to introduce our friends here. I'll start with the youngest member, Akshay Mishra, who is a founder and CTO at DSP Works, which is an electronics and IoT company in Bombay. He did his BTech at MS University in Baroda and MTech from IIT Bombay. These are things like electronics, system design, and embedded signal processing and stuff like that. He's also an amateur radio operator with the call sign VU2BUG, in case you want to remember that. So he's done some cool things in the past, but I'll let him speak about that. Like, for instance, he developed the first thin client in India on an ARM9 to stream from Tata Walkie to TV, from Tata Walkie to TV. I'd like to know more about that. And he's done some cool work with radio over IP. And we'd like him to speak about that also. Uh, More about that later. We'll move on to Raghunath Iyer here, who's also an IIT Bombay alumnus. He's a CTO of Qualys Networks, and you've seen him in the past in many swarups, including as part of the jury at the e-Yantra competitions. He came and gave a talk to our interns, and he's our go-to person for anything to do with electronics and products and stuff like that. So, as you know, he's got a large amount of experience in network security, and he's built ASICs for network processing. And apart from that, he's a real engineer. A real engineer means a tinkerer. And last but not least, we have Sri Kishore Babu here, who is the Deputy Director General in the Department of Telecom, where he's looking after something which is very close to our hearts, which is research and development and innovation, especially the innovation bit. And he's done a PG diploma in public policy and management from IIM Bangalore. So he's a telecom professional with a large amount of experience in public policy development programs, projects of national significance, where he's actively coordinated, with international organizations, national organizations, industry, and stuff like that. So he's very important when it comes to deploying any cool new communication technology in the country. In fact, he's facilitated the National Digital Communications Policy in 2018. And his efforts led to the delicensing of the 5 gigahertz Wi-Fi spectrum and the license exempt bands for short-range devices and stuff like that. I hope he'll speak a little bit about that. But the reason we have him here is because he's a champion of Indian innovation systems and Indian entrepreneurial abilities of startups and all these things, which is particularly useful to us. And he's particularly open-minded about collaboration of stakeholders across borders and stuff like that, which is very, very refreshing to see. So the context of this program is Akshay and Raghunath are trainers in our e-Yantra Innovation Challenge, which is just completed registrations now, and the challenge formally begins from tomorrow. And the Innovation Challenge is e-Yantra's attempt to help students learn about the process of taking ideas into startups. We've been doing it in very ad hoc ways in the past. This year, we are doing it very differently. This year, we have made a theme of disaster management, and we've got a 3-stage process in which we will help students learn the art of taking an idea into a startup. And in this, what we are doing is that the first stage is a training phase where we have experts. That means that you have disaster management experts who will talk about what are disasters and all that. So we have Professor Vinod Menon, who was the co-founder of the National Disaster Management Authority. So he'll be talking, and he's extremely well linked with UNDP and UN organizations and World Bank and all that. And he'll talk about what are disasters, which are the various types of disasters, and he'll give you a total 101 on disasters. Then we have Sumit Sen and Uday Ramtirthkar. Sumit is a senior scientist at the GIS lab in IIT Bombay, and Uday is an old hand in as a principal consultant of TCS. and they will talk about the disaster management informatics tools, right? The model-based design tools and post GIS based databases and all these kind of things. And then Akshay and Raghunath are going to talk to you about, are going to teach or train the students in what are the communication tools, because the most important thing in disaster is the first thing that breaks down is communication. First thing which is needed is communication. What are the options which are available in the communication space, and what's all the cool technologies and all that which are available? Then after that, we have a tech sprint, right? So we have first an innovation and entrepreneurship part where we teach you how to articulate interesting ideas that you want to build. Then tech sprint where we mentor you to actually build these things, and then a startup sprint where the best ideas are taken and we help you do a startup out of them. So that's what the innovation challenge is. But when we were listening to Akshay Mishra and Raghunath Iyer about what they will talk about, we got this idea that hey, this is really cool. I have not heard of many of the things before, especially what are the options in communication technologies and all that. So we decided to have this program, and we were also introduced to Kishorji from Department of Telecom. So we thought that this can make for a very interesting conversation about what are the cool communication technologies which are around and what we can do with them. Okay, so I'd like to first start by throwing a question to Akshay. That it's quite interesting that you talked about Wi-Fi, BLE, LoRa, VDSL, GPS, GSM stacks, and stuff like that. And something that struck me is that you said that the majority of the work has been done in Bangalore. Now, I thought that much of this stuff comes from Silicon Valley and from China, Qualcomm and stuff like that. But you're saying that all that work is done in Bangalore. Please explain that. Explain yourself. You're muted.
I'll explain how I did it.
You're still muted.
I think he got cut off and he joined back.
Okay.
No, I think I should be audible. Am I audible now?
Oh, yeah. Yes. You got two windows open.
Yes. I joined to the phone also.
Okay.
Yeah. So in 2001 from IIT Bombay, I joined a company called Epigon, Imused, a company called Imused, which was it was a spin-off from Sasken, which worked only on DSP algorithms, DSP codes on audio and multimedia.
Sasken was Modi and gang.
Yes, so it was a spin-off from Sasken. So
okay.
Team from Sasken spun off and they started this company Imused. And it was a fun group of, there were only two IITs there, IIT Bombay and IIT Kanpur and IIC Bangalore. There were only three alumni there and working on all DSP, audio and video. And we were hand coding all the algorithms, be it your GSM AMR, be it your audio codec, be it your H.264 or a MPEG-4 or a MP3. These were all hand coded on a TI DSP or a Cypress DSP. And what used to happen is you take a TI DSP, you take the compiler, you code it, from the compiler you realize what is the MIPS. It was, if I take the case of GSM AMR on which I worked, it was 140 MIPS directly from a vanilla compiler from TI Texas Instruments. Now I sit and did a hand code, it went to 7.5 MIPS from 140. And this was not only me or only this company, there are similar such companies which worked on all these algorithms sitting in Bangalore, which were then your SIRF did on GPS codes. So GSM was also done in India. Similarly, all the algorithms, they were hand coded in assembly in India, in Bangalore. And then they formed once it was tested, there were test vectors which were used to test the input stream on your algorithm and on the optimized code. And it has to be bit compliant. Your audio should not lose any quality. Your video should not lose any quality. So there are test vectors, test streams which are tested. And once this is found compliant and error free, the code is then integrated in the chip itself over time. So initially what went is a TI DSP and an external program memory which is using it. And slowly when volumes went up, when the dependency on this thing increased, when the price became a reason to shrink it further and bring it into a single chip, all this code went into the same chip. So TI took this audio codec, took their DSP, made a chipset out of it, and gave it to Nokia or gave it to somebody else. So what happens is all of this together over time evolves into a single chip. This is not a matter of 6 months, 1 year, 2 years, but over time, maybe over 3 years, 5 years, all the algorithms sit together, go together in that form assembly coded code, and then released as a single SoC. And so, and from what I know, my batchmates, my friends who are working, so this has happened for DSPs, multiple flavors, ARM, ARM7 mostly, and then it has become industry standard. So the silicon comes from anywhere in the world, but the firmware development, which goes inside the SoCs, quite a lot of it has happened in Bangalore.
So from what you said, there are a number of questions that come to my mind. I'll ask them slowly, and before I get to those questions, I think I'll ask something to Raghunath. Right? From what Akshay is saying, it seems as though it's only the IIT people who can do all this work.
No. I'm not claiming that. There are IITians, there are non-IITians. I'm not trying to create a divide there. No.
I don't believe that at all. In fact, I feel that there are kids outside IITs who are
Definitely
better and they're more dedicated and stuff like that also. So I'd like to just remove that bias if it's there in the mind of the viewers of the program. The other thing is that you mentioned all these cool things that you've done with communication protocols and stuff like that. Okay. But who owns the IP of it? That's the real value, right? Who owns the IP?
So if I take the case of GSM AMR, which was my first code I worked on. So a GSM AMR is a code which has been written by the GSM body. The reference code, the bit vectors for test are available in the public domain, or were available in the public domain. They are still available in the public domain. So there is no such IP in terms of the algorithm. It is then how well you hand code it or implement it and bring it to the target MIPS level, that it has to not exceed 10 MIPS at a 14.6 kbps kind of audio throughput. So there is no algorithm there. And even today, if you see the speech codec world, all your speech codecs are in the public domain. So even the most popular, not the most popular, but the lowest bitrate codec 2, which has been developed again by a ham radio operator, David Rove, that goes up to 700 bits per second, completely open source. You can take the code, compile it, and start using it. So the IPR for H.264, again public domain. Implementation, achieving in a target processor, and then getting it with that computation with a fixed point or a floating point implementation which is constrained, getting it to work in real time is the engineering challenge, not the algorithm. The algorithms are all there lying free.
So Akshay, I will beg to differ here. Sorry, Kavi, if I'm interrupting.
Please do.
I think in the commercial world, the IPR is not necessarily algorithmic. IPR is also effort that has been spent in implementing it and making it efficient. And folks don't want to reinvent this. I mean, commercially, it doesn't make sense for me to keep redoing this optimization time and again. And it takes time. It takes 3 years. It takes 2 years, whatever it is. So very often, if I am a new kid to the block, if I am a new communications chip maker, I would license the code from somebody else. If I have to fit it competitively within a certain silicon die space, why would I go and do it again? So in that respect, the IPR is, yes, it is owned by the folks who provided all these kids the vision, and then they said, go do it, I will sell it, I will use it, I will resell it. So yes, the people who built it here unfortunately don't own it. Yes, the algorithm is still available and they can go again and re-implement it. But that's like you're going to expend time and energy and effort. Am I right, Akshay?
That is correct. And there is also a risk in terms of getting it right. It is not a trivial job to put the bit streams, get it right, and it is not worth anybody's time if it's been done right once. So I think what he's saying is right. So in terms of IPR, if I say patent, no, it may not be patentable. But in terms of IPR, in terms of anybody being able to easily reproduce it, there is a significant amount of IPR, maybe more than having written the original algorithm.
Okay, but isn't there a chance that once you had the opportunity to work on these kind of algorithms, that you can think of a better way of
Yes,
a
yes, yes.
better
There is,
algorithm?
there is definitely there.
Couldn't that be patentable?
So that is patent of the implementer. Then it cannot be a patent of the from where I am copying it. So in used, there have been many patents there. That while working, we realize that this thing in GSM AMR or this thing in MPEG 4 is not worthy of how it is. So it should be redone. So those algorithm inputs have been submitted, and that has been brought out. So that happens.
So Kavi,
Okay.
we all talk
Yeah.
of patent in a very, I mean, in a sense that it'll earn us a lot of money. But it'll earn us a lot of money only if it is so fundamental that nobody can bypass that. And if you have to be doing something in that subject matter, that's the only way to get it done. In which case, owning a patent is really powerful and you can monetize it. Otherwise, I mean, just by changing the processor, just by changing something else, I can certainly work around any patent. So, patents value is in the generalization and still applicability across a wide spectrum.
Okay. So Raghu, that brings me to you. I'd like to sort of just bounce this off you. When Akshay began speaking to us about technology for disaster management and stuff like that, he talked about a number of things. He talked about open loop technology, where he talked about open BTS, and then he talked about DECT. And I remember one Dr. Bhaskar Ramamurthy was doing some work on core DECT in IIT Madras. And then he talked about Wi-Fi based calling using asterisk, and all that.
Asterisk.
Asterisk. So what are these technologies? Could you just kind of, highlight them to our users, our viewers here at least?
So so very broadly, uh, communication from one endpoint to the other endpoint hops through multiple technologies. I mean, at the very beginning, you had a wire and people spoke across a wire that was dedicated wire. Then you had switching, and then of course now communication hops across multiple media. So the nearest hop is one loop, and then there is a backhaul, and so on. So now when you talk of asterisk, it's like a PBX. It's like your local switching exchange. And asterisk comes in where you want to convert from a digital domain to an analog domain. I mean, today, of course, the backhaul is also not necessarily analog anymore. So in the, let's say, 5 years back or before LTE came in, all your PSTN communication or your regular telephone was pure analog or was TDM and TDM on even lines and T1 lines, 64 kbps lines taking from the endpoint at the home to the telecom switch at the back end. Now, at an office, if you have an IP backbone connecting multiple remote locations over an IP backbone, you do not want to have a separate telephone interconnect between these offices. So your IP backbone itself can serve. But then all your local voice equipment are legacy and they do not necessarily have the wherewithal to communicate on an IP backbone. So that's where Asterisk came in. Asterisk came in as a soft switch. So you could have, it was compatible at the signaling level with all the other analog domain, PSTN domain signaling technologies to terminate a phone number and so on. And then it would transfer the data onto a digital channel to the end PC, which is running a VoIP software. So you take VoIP connections from the endpoints, which are soft phones or VoIP phones or even your regular PCs acting as a phone, and then data goes over IP to Asterisk. From Asterisk, it can go to the other end, which can be over a PSTN, or it can be yet another IP connection, another Asterisk box. So it becomes a soft switch. It's a equivalent of a telephone exchange, but a very small form factor, low impact telephone exchange on your premises. So at the end of the day, you have data, voice data moving across multiple technologies. and technology components that you spoke of are applicable at different legs of these.
So could I, for instance, implement this on a Raspberry Pi and make a Raspberry Pi based exchange?
Yes, of course. Yeah.
Okay,
So
that's really cool.
I have,
And some of this codec business that Akshay talked about, right? The codecs become necessary at the asterisk level because now you are going to digitally send the voice across on IP on one side and it's analog voice coming on a telephone line at the other end. So it has to be digitized, it has to be codified and decodified, and that is where all those MIPS part of it comes in, because you want an efficient implementation that does not compute, that does not consume too many MIPS.
Okay, so this is interesting. Now, I'm a simple CS guy who doesn't think very much about the communication protocols and all that, and say that I want to do something useful in the disaster management space. And I know about Arduinos and RPIs and stuff like that. So, could you kind of give me some examples of stuff that I could do if I had access to these libraries and this kind of technology?
I think best is Akshay to speak about it because he's done it.
So what I'll say is, when you think of any or multimedia or digital requirement, you should think of it as only an interface or a leg of an entire organism, which can connect by means of a gateway. And asterisk is one such switch, which Raghu just explained, which interconnects multiple such protocols. So I have my landline calls in my home, in my office, they all land up on my phone. I don't have to, if my landline rings, it comes to the same device. My cell phone rings, comes on the same device. My office phone rings, comes on the same device. It is all because I have a soft switch set up in my office. I have a soft switch set up at my home. These soft switch together, they link to a trunk on my cloud. I am on through my phone connected to the cloud. So wherever the call comes, it goes to the cloud. From the cloud, it comes to my BearShip, and all of this is open source. BearShip, Android application which runs SIP client on my phone, asterisk in my office, asterisk on something similar to your Raspberry Pi, but that is running on a Blackfin DSP. Again, open source implementation, sitting in my office, sitting at my home, and it is running on Linux in the cloud. So all of this comes, I don't have to go anywhere. You could ring my landline and I could answer it from anywhere in the world.
So Kavi,
through my phone.
Yeah.
Think about Google Voice. Everybody goes after Google Voice, right? So Google Voice is an example. So that's one example. There's a company now, very popular company called Ring Central. So people getting telephone lines actually just deploy Ring Central, and then they are on an IP backbone. They have PSTN connectivity. They don't have to do anything at their office. They just have an IP connection. They don't necessarily lease T1 even lines to a telephone exchange anymore. Ring Central does it at their backbone, but they get telephone numbers at their office, right? Yes. So these are all modern ways of skinning the same old telephone number system, but in a centralized place where it is all done by a service provider.
Okay, interesting. Now this is where I'd like to pull Kishore Babu into it, because I see this whole telephony business getting undermined by this, and I wonder how Department of Telecom is coping with all the new technologies which are coming on the horizon, which would be very difficult to kind of manage. Like for instance, making a call abroad now has become so easy. I remember 20 years ago, if my dad wanted to call me in the UK, it was almost impossible or very expensive. So there are all these revolutionary technologies becoming available. So how does Department of Telecom actually cope with this? I mean, what are the mechanisms that you have, and how do you regard all these new options which are coming up, like for instance asterisk and these kind of options?
Thank you, Professor. For the quality purpose, just I'll keep my video off. Is my speech clear to you?
Yes, very clear.
Yeah, thanks very much. And I'm very happy that I got introduced to this forum from you as well as Akshay. And I saw the brochure what you shared about what e-Yantra has been doing on robotics front as well as all other innovations part. So I'm happy to be in part of this group, as well as I also welcome you to the work what we are doing under Department of Telecommunications. You said rightly that telecommunications are transforming very significantly as new generation technologies, especially on access front. They are transforming day by day. We saw 3G, we saw 4G. Now almost 5G is here in many of the countries, and now of course I also hear that work on 6G has already begun in the country in some of the Indian startups as well as some of the MNCs as well. Okay. And coming to this, specific area, what you mentioned as part of policy enablers, some of you might have heard about something called National Digital Communication Policy 2018. Around 2018 October, it got published, and it's available on Department of Telecommunications portal, where you can look at the different strategies what DOT is envisaging to roll out, and as well as some of them are already in progress, and some of them in final stage of implementation. The idea is that there are certain goals and targets have been set for 2022. What would like to accomplish in terms of connectivity, in terms of IoTs, and as well as making spectrum available for R&D, etc. Now, coming to the most interesting part, you mentioned about this robotics as well as disaster management communication, as well as also 5G front. You might have heard about Department of Science and Technology. They're coming out very huge, I should say, innovation centers or labs, especially on cyber physical systems. I think the program costing is around 4,000 crores. They're coming up with a lot of incubators in the country, which will be working with many of such R&D centers working in different departments. Like for example, in DOT, we have got Center for Development of Telematics. There is something called CDAC under MIT. MIT means Ministry of Electronics and IT. Just this for information to all the audience as well as students who are taking part in this session. And there are also several centers of excellence under Ministry of Electronics and IT. And you also may be knowing or might have seen in media that all academia, including several IITs, IISc, and some of the Government of India labs like CEVIT and Samir, which are located in Chennai, all together they're coming out with something called Consortium 5G Test Bed, which we call it as a white box kind of test bed where they can put in their software or algorithm as well as the hardware devices in 5G end-to-end infrastructure starting from UE to 5G packet core, including in between ORAN as well as RAN, including MIMO under all all these new technologies which are coming as part of the 5G portfolio. The idea is that anybody, any startup or any SME or any company, whoever working on these technologies, they could come, they can bring in into any of the subsystem, even in a means
Oops.
end testing as well as how these performance objectives are met. Okay, this is the one of the objectives of 5G testbed. Perhaps by March 2021, this 5G testbed is going to be ready, making available across different institutions, starting from IIT Bombay and Kanpur, Bangalore, and as well as Chennai and Delhi. These are some of the places I mentioned, and there are few more things what I want to share with you. This actually to add to the information what you may be already having, like for example, few years back we were under the view that the 4G as a technology, perhaps we still have to depend upon global MNCs, and Indian companies may not be still working on this at core technology part of this 5G subsystems. But for last 2 years, of course, our members can watch who we started in what I should say, we started developing preparing a heat map looking at who are all the Indian companies working in 4G as well as 5G technologies as well as related technologies like IoT, M2M services, etc. To our surprise, we saw almost like 10 to 12 companies who were working on core technologies, starting from big companies like Tech Mahindra, Wipro, as well as many of the startups and SMEs in Bangalore, Pune, and other area. They are working on the core technologies dealing with 5G as well as 4G. So, at technology level, establishing the core parts of the technology, yes, the competencies are very significantly growing in the country. And on the second side, especially for the application front, where you are discussing with the your students as well as other members here, you might have heard about something called how applications and use cases are going to be important to create demand for 5G and other services, because the capabilities which are extreme capabilities, let us call for 5G, which have a lot of significance for with regard to industry verticals. It could be smart cities, it could be smart communities, or agriculture, as well as disaster management, banking, with even automobiles, that V2X kind of application, medical electronics, you name it. When we see any of the global events, 5G usage case labs is something, or 5G use cases is one of the very important area, and robotics, especially in terms of industry 4.0, or even for V2X kind of communication and disaster management, safety of safety of people as well as resources in mines. These are all some of the very important areas, including agriculture, which are gaining a lot of prominence to be worked further in the Indian context point of view. So, we are working with other centers of excellence. Perhaps as part of the discussion, I may share with you more about, as Professor Kavi wanted to know more about what is that with regard to spectrum, what is made available as part of delicensing bands as well as short range devices, etc. In case there is a discussion as part of this session, I'm willing to share more about that. How R&D spectrum is being made available, especially for all these IoT and MTM kind of communication. And as the discussion progresses, I would be willing to share more about what are the other infrastructure elements in terms of structures like TSDSI, Telecommunication Standard Development Society of India, which is exclusively working on, as Raghunath rightly mentioned, making a patent is one part, and coming out with a standard essential patent. How we can fit into the global system of things, or global scheme of things, is something very critical, where the Indian academia are pushing one of the standard, especially for 5G, a kind of rural scenario which we call LMLC, low mobility large cell, as one of the standard, which right now the meeting is going to start from Monday, that is tomorrow, as part of ITU standardization of 5G, where version 16 of the release 3GPP, we are working out how India could play or make baby step in bringing out some of the patents which may turn out to be standard essential patent, but down the implementation part. So with this, at this moment, I want to listen to you more about, and I also would like to share with you, we have got certain platforms like Technology Dots, as well as we have got a social media platform which we exclusively opened for Indian technology companies. It could be startups or SMEs. It's a place where we want to discuss and share about all the opportunities as well as challenges, what you want to bring to the notice of the government of India. We would like to, kind of facilitation, and what kind of support we can, extend it to you, which we can share in the, further in the discussions. Thanks, Professor Kavi. At this moment, I'll be more
Thanks,
on
thanks.
mute. I would like to listen to you.
Sure, sure. In fact, let's take the conversation back to what we are hoping to achieve in the disaster management innovation challenge, right? So, Akshay, you mentioned a number of technologies. You talked about radio over IP, and then you talked about a very fascinating thing that you can get satellite imagery of India, right, in real time, and you can have a receiver that you can buy off the shelf, right, and get these images. It'll be useful to know a little bit about this, because then I don't have to go to ISRO and running around here and there to get these kind of images. They're in the open domain. That's one thing. And the other thing is, how can we use this corpus of youngsters out there, right, who are willing to learn? What are the kind of problems that we would like to throw them against, right? Which might lead to some really interesting things coming out. So I actually have three questions in one. One is, of all the technology stuff that you mentioned, one is that satellite thing struck me. Then the radio over IP and software defined radio and stuff like this, which you mentioned, it sounded very, very compelling to us. And uh, how might we work with these youngsters, right, to do something useful in this space? Because there's a lot of spoon feeding you'll have to do at the beginning, because they're never exposed to these kind of things anyway.
So, excuse me. What I would say, or how I have learned, is to give problems and then try and there has to be someone amongst us here who can be at a higher level and give them jigsaw puzzles which can then fit and start talking to each other. That is what we need to do, which is what we discussed, I think, during the last conversation also. which is where Raghu mentioned that we need to define these small problems, which could be library problems, which can then feed into one large problem. And we define the interfaces, the APIs in terms of how they're going to communicate with the backend or with each other. So we spend some time in terms of defining this backend system or the motherboard system, and then every interface or every problem is only a line card which is going to fit into this particular setup. Is my way of getting people to work at it. And we need to, just like IIT में आने के बाद में you realize कि इतने quizzes हैं, इतने exams हैं और भागना है, you need to be given a timeline, you need to be given a schedule. Everything is available in some form or the other, either in terms of document or in terms of reference implementation or in terms of an exact implementation in the open source public domain. GitHub, GitLab are very large repositories where 80% of things are available. We need to tell them this is what is expected, break it down into something which they can do in 3 months timeline and deliver. Some could be simpler problems, some could be complex problems, but based on their appetite, their time availability and their interest, they take up a low hanging fruit, a large hanging fruit, and then fit into this large jigsaw. And then we build the entire maze together.
So Kavi,
I think that is...
Yeah, so to support Akshay, if we really want to get these students to build something that is long lasting and that has significant value, it cannot be done in just 3 months. It can be a component that they can build, and they cannot see the big picture where they are today. They are not in a position to appreciate the big picture and break that big picture down into smaller components. That's the job that people like us here have to do. And we have to coach them that they are part of us, they are a quote unquote, a component in the bigger assembly. And then they deliver to that component. Yes, there will be competitions within that. There will be more than 1 or 2 teams trying to build it. But the interfaces, the APIs, I like the concept that Akshay said, line cards and motherboards, right? The PCI bus enabled motherboards and line cards to be compatible with each other and create an entire ecosystem, right? So just like the PCI bus, we should have our disaster management interface stack or communications interfaces that we can define. And then, yes, for each specific region or domain or problem statement, there can be sub-assemblies that can be spec'd out.
So that's very useful to know. So until now, the way we've been running this competition is that until last year, is that you think of a problem in your vicinity, you give us a proposal to solve it by building a machine. Then we used to give you an innovation and entrepreneurship workshop, basically, which shows you how to filter out the things to come down to something which is actually practical, because many students don't have exposure to technology in the right way, or any exposure to technology. They can't think of interesting problems, and plus culturally we are not equipped. Culturally we are taught to be knowledge consumers. So, sab kuch bahar se aata hai, you just use it. No, right? You are not.
It will still be like that. We'll still enable them to solve problems, but the theme behind it is something that they may not be able to come up with.
Exactly. So I feel the burden is on us to do our homework beforehand, and we can still encourage them to come up with their own ideas. But I think we need to take a grand picture of the communication stack that we have in mind for disasters, break it down into bite-sized chunks, and advertise it. Right, where 3 teams can pick up one project basically, and they can all build their own versions of it. So you have some redundancy and see what comes out of it.
And that's why, and I think Kishore sir here can also add value, because I have seen in his forum, he's been asking and encouraging rural communications, and there will be requirements that we can tailor to fit within the blueprint that he is visualizing.
Okay.
So that's one background here before I think I'm just interrupting. So Mr. Kishore Babu started a forum or a group, I think about now 3 years ago or 2.5 years ago, which is a WhatsApp group, which is a very informal or casual way how a government officer and government reaches out to everybody. And that WhatsApp group is now, I think, to capacity. And Raghu is a member there, and he has been very proactive. He was earlier a part of DDG policy, and now he has moved to standards and research and innovation. So I've seen him in terms of intent, in terms of how he needs to get across and talk to startups, large organizations, and bring them together on a common WhatsApp platform has been something which is phenomenal. So what Raghu mentioned, and it was Raghu's idea to bring him here to add value, that for e-Yantra, somebody like him is going to bring immense value in terms of reach, and his simple concept कि इसको कैसे scale करना है, I think he has solved some problems there.
Okay, so that's one bit of homework that we have to do in the next few weeks while the training part is going on, and then you'll have the INE part and stuff like that. So we have, I think, 2 to 3 weeks in order to put our heads together and come up with problem statements of this kind, right? So having said that, you mentioned a bunch of technologies which I found very intriguing, right? You spoke about software-defined radios. Can you tell us a little bit about those?
So what I mentioned in software-defined radios, I mentioned the public. So I had touched upon all the publicly available and open source resources which students can use. So in that, what I mentioned about the software-defined radio was the RTL. So Realtek has a RTL 2832 is the chipset, which has gone wildly popular. I don't think they even imagined that this can go into the kind of solutioning that it has really gone into. And that chip with a USB interface, it has become up to 1.7 gigahertz. It is not a complete SDR in terms of your other frequencies, but up to 1.7 gigahertz, which is pretty neat in terms of learning signal processing, learning your sampling theorems, learning your zero frequency, zero IF sampling, and bringing it onto baseband. So all you learned in your DSP can be implemented on Linux very easily in a simple a C code and a Python code. That is one aspect which the RTL SDR solves. Other fundamental thing which RTL SDR solves, which I mentioned and brought you about the satellite receiver. So the NOAA satellites, the National Oceanographic Department of US, so they have satellites going around in the low Earth orbits, which send down the satellite imagery at 1.5 gigahertz, which is a high resolution picture, and at 300 and in the VHF band, 340 megahertz and 144 megahertz, somewhere around 144 megahertz, which can be received by the RTL SDR by means of an antenna. You can decode it and you get a complete reception. So all you require is a RTL SDR, a tuned antenna which can point to the particular satellite, maybe a antenna rotary system which can keep track of the satellite when it's moving to keep you a good SNR, and then your Linux code. And all of this is available in the public domain. You need to understand and have the intent to decode it, a Raspberry Pi, and this will be thrown on the web page of the Raspberry Pi for you to just keep on browsing. As you rightly said, you don't have to go to the ISRO website or the NOAA website to see that particular image. So that is what I had mentioned.
So what is the hardware that you need, and is it legal?
Yes, the hardware is legal. So RTL 2832 is the USB dongle.
No, but you said that a satellite dish of less than half a meter is not legal.
No, that is for transmission. So when I mentioned that, I mentioned the likes of Kuiper Belt and Starlink, which is coming up for internet reception. That may be illegal in the country right now, but RTL SDR, and that requires hardly a VHF antenna is all you require. So there is a VIP antenna. So RTL SDR with a VHF antenna connected to your Raspberry Pi is all that is required. RTL SDR is $32. A VIP antenna is from 300 rupees. A Raspberry Pi 3 is going to be 3,500 rupees. You may require some motor to ensure that the antenna is pointing to the satellite always. That is going to be some sophisticated stuff. Otherwise, something less than 10,000 rupees is going to give you a weather station of your own.
It's a beautiful project to do, and I think a number of teams should take up this kind of thing. So this is pretty cool. I'd like to ask Kishore Babu here about this Starlink that you mentioned, right? What exactly is Starlink, and is it an issue playing with this technology in India?
Starlink, I don't think it's commercially available in India. I don't know about the satellite when it passes and what is the as
So
even
can
for
you
that.
tell us a little bit about it before we?
So these are your so Tesla and Amazon. They have launched low Earth orbit satellites, which are going to beam internet to the masses who may not have access to the internet, high speed internet, through conventional means. And so by satellite, you will be able to get a low latency internet. So your signal, you beam up to the lower satellite. From there, it will go to either the Middle Earth or a geostationary satellite, and then pointed down to the Earth station, which is what is going to be the two-way communication link for you. You get a typical latencies of about 30 millisecond and 25 millisecond is what we now read about. I have not tested this, but the terminal, it's not going to be very expensive given the kind of people who are involved and their tendency to bring it to the masses. In terms of its commercial availability or legality, I think if there is an opinion or an insight, again, we don't know if there is some study which is available, but maybe Kishore Babu may have some input on that. So Mr. Kishore Babu can advise on that. But this is too early for thinking about such a thing being available commercially and widely. But once it comes and it's available, it solves a lot of challenges in terms of disaster. Being a ubiquitous communication link anywhere, I think it's a wonderful tool.
No, but everybody talks about leapfrogging nowadays, right? Most of the time, India has spent its time playing catch up with old technology, and by the time you got it, you're like even 5G, we are kind of getting there, right? But wouldn't this be quite amazing for things like agricultural use, where you have these, farms far away from communication lines or power lines and stuff like that, where if you can have this kind of technology available, you could do some really amazing work, and even wildlife monitoring and forestry and all these kind of things. So perhaps I can ask Kishorji here about what is the bandwidth that this operates in, and what would be the issues about using this kind of technology, which
With
looks very
regard,
exciting.
yes, Professor, it's very, I should say, the dream of making internet available at affordable cost to masses ubiquitously is one of the very important, objective even from a public policy perspective. In India, if you look at SATCOM policy, primarily, I should say coordinated and managed by Department of Space. A lot of discussions are happening with regard to what way we can bring a kind of liberal winds as well as how making such satellite transponders as well as bandwidth could be made available for more socio-economic purposes. I should say that a lot of discussion is happening. Some of the, policy directions may come out in a soon because that's what we also heard recently. There was a media news about discussions about these transponders, how they could be more available from the foreign satellites, etc. But however, one thing what you mentioned about low Earth orbit as well as MEO kind of satellites, where perhaps even ISRO is planning to make such a broadband, I should say, a kind of beaming in areas where there's a coverage challenge, or how India could be can be covered with high throughput satellites in rural areas using ISRO's different bands which are under consideration. That is one of the other serious topic where ISRO is already doing or dealing with them in terms of development as well as the strategic planning. But with regard to this new technologies, what they're coming with regard to receiving, with I should say commercially very affordable kind of receivers. Perhaps I can get back to you with more information about what is the current, I should say, approval kind of thing. Is there anything necessary, or anybody could deploy and start tracking the satellites of foreign origin? That part immediately I cannot answer to that. I'll get back to you on that front. Coming to this 5G use cases, what you mentioned about agriculture and other things, yes, for 5G as such as a terrestrial technology reaching them, it could be a matter of time. Perhaps it may take a little more time to reach remote rural areas. But yes, satellite technology as well as other means. Like for example, somebody was even discussing about how VHF technologies could be used for far-flung areas where there is a lot of rural challenges with regard to small mountains or that hilly areas, how even it could be used. So I mean, maybe specifics, if anything you want, Shule, I can come back to you as well as to other team members if the students, if they would like to take up any project. We can also liaison with them in some of the startups or other companies who are already working in this satellite projects. Like for example, some of the projects could be in S band. Like there are certain products which they're working on. How can we have IoTs in S band, especially for logistic monitoring as well as resource management in airports, as well as moving trains, as well as some of the, I should say, ports, etc. So these are also some of the interesting areas which we could think about how satellite current bandwidth could be used. I can get back to you with more with specifics.
Okay, this is very interesting. So, what is the bandwidth that we are speaking about in terms of Starlink and this family of satellite applications?
So this is the, I'm just
Uh,
showing you the speeds. I'm interjecting here. I'm just showing you the speeds and the ping latencies for a Starlink, which is Tesla. If you can see the screen. So
Okay.
these are confirmed tests. So you get 44 Mbps download, 15 Mbps upload, and a typical 30-40 millisecond latency. And there are about 2,800 satellites planned in the low Earth orbit by Starlink, and a similar number again by Amazon.
This is actually quite revolutionary.
Yes, so this is disruptive.
But
Yeah,
but
sorry for
but
the.
shouldn't we be sort of thinking of anticipating this kind of stuff and building applications and building boxes which can work with this kind of technology,
But there has to be a
thereby
regulatory
leapfrogging?
clearance. There has to be a regulatory clearance because disaster defense, they are going to benefit immensely. Imagine a 20 kg battery pack for setting up a link and a VHF HF set could change in a matter of moment to something which is as small as a cell phone. And because there is an end-to-end link, you can have an end-to-end encryption. So you are more or less safe in terms of the communication link. So it is disruptive. There is a benefit, but there are regulatory things which may come in before you get, and if you don't get to test it, you're not going to do much about it.
Okay, so the fact is that if we do want to start anticipating these technologies and thinking of building products to anticipate these things, obviously it means that the products will not be able to function in India, but we can build for the export market and things like that. I'd like to know how these things are actually regarded as to when one makes a policy. What are the kind of things that one has to keep in mind? I'd like to ask Kishorji about this because this seems like amazing technology. But what would be in the minds of policymakers when they are faced with these kind of disruptive options in front of them?
yeah, thank you, Professor, for asking that question. As Akshay mentioned, yes, it's a, if you look at the throughputs available as well as latency, how minimum we can get using such technologies is really fabulous. If you look at current satellite policy point of view, for any commercial satellite services in the country, uh, either it has to come through ISRO, that is using its approval process for engaging the transponders, or we should be having the gateway in the country so that the information what goes through, there is a accessibility for Indian agencies, considering its ubiquitous nature of the satellite communications. See, there is no doubt from the policy perspective having such communication access wherever you want in the country to meet any emergency as well as disaster communication needs, it's significant, very significant. But however, from policy perspective, there is also a thought process that yes, if somebody would like to deploy commercial such services in the country, the gateway requires to be established in the country so that data remains here, and as well as access to the data to handle any kind of access by the law enforcement agencies. That is one of the minimum requirements. And other part, I mean, one of you mentioned deploying, bringing in one technology, already there could be certain substitutional services, perhaps maybe from terrestrial point of view, who are providing similar nature of broadband services. So naturally, regulation from licensing of view, what kind of licensing would be made available to ensure that different services providing different platforms providing a similar service would be having a kind of level playing field. That would be one of the important points. What would be in a policy makers point of view, that yes, whether all service providers are having same level playing field.
Kishorji, you have very eloquently and very elegantly answered that question, giving an idea of the entire dimensions of what goes into policy making, and uh, it's really interesting to know. And I realize as soon as you say gateway, it means that anything directly connecting with the communication from a satellite would not be advised in this kind of case. It has to come through a gateway. That means it has to be a terrestrial deployment. Uh, for various reasons, security reasons, and all sorts of things. So we do understand that, but I think there is still a lot that can be done using direct satellite connectivity from satellites like Nova, where you're just receiving, and then you can do all your other stuff on the terrestrial network.
So
So
Noah is
I'm
free, sir. There is no
no,
restriction on the
absolutely.
Noah. Yes.
That's what makes it very exciting, that you can get direct access to information like this, and I can think of many compelling use cases of stuff that students can build based on that, right? Like you don't even need Google Maps. You can bypass that entire thing if you are in very remote regions and stuff like this. So I think we've come to the end of our time. It's been very engaging, and I think this is the start of a conversation. Raghu, thanks for having uh, consented to join the discussion, and bringing Akshay into our sampark, and now Kishore Babuji from Department of Telecom. I've stopped believing in coincidences, and like Vinod was also saying this morning, we have an amazing team which is growing as time goes on, with a sense of purpose, with a sense of mission. And I hope Kishorji would also like to join us as one of the advisors in the entire e-Yantra universe here, which is basically trying to get out there and help our young engineers do something cool with their lives, right? Something very empowering, and something which can help not only themselves but society also. So I'd like to thank you all. I'd like to thank the members of our team who make this possible behind the scenes: Suprabha, Ratin, Deepa, Aditya. If you can just unmute yourself and take a bow from us, that would be nice. Right? And so these are the team which actually works behind the scenes. So we are in our 7th episode, and I'm getting more and more excited by the possibilities. So what these programs do, essentially, it is building a community of young engineers. We are offering them cool ideas. We are offering them cool role models, and trying to help them see engineering the way we see it, as something really exciting, and to approach life with a spirit of play and do something really cool. So that I'd like to thank our guests for spending their time with us. Kishorji is parked in a car outside Delhi, and he'll be home in an hour's time, hopefully, once he takes off again. Raghunath is at home, and Akshay is at home, so they are fine.
Yes.
But thank you all for being with us. We really appreciate it. And God bless, and Jai Hind.
Thank you. Thank you very much.
Thank you very much, Professor, and thanks Raghu and Akshay and all the participants here. Have a good time.
Thank you.
And
We hope to see much more of you in future, sir.
And thanks to Kishore sir for accepting the invitation and joining. I think he can add a lot of value from a policy perspective, and he'll also get inputs from the team here as to what we are trying to do, and take it back to the government and place in the right ears as to what's happening.
Absolutely. There's so much that we can do with these young people that we have access to and who are working with us. So with that, I'd like to sort of end today's program. Kishorji, thank you very much for being with us. And likewise, Raghu and Akshay. Thank you very much.
Thank you very much. Thank you, Professor. Bye-bye.
Thank you all.